Good afternoon. We start week 5. Midterms are out there posted, and we're picking up uh, chapter 13, 14, and 15 today. And just a reminder, next week, the value stream maps are due. And I need to go check the wording on how the assignments put out. It really is just the uh, recording the building of a peanut butter and jelly sandwich or any 2 ingredient sandwich. And then you're going to use the chart that you downloaded from chapter 5 on your yellow belt and put in the times from the recording that you made for each of those steps. So you're going to start off with nothing out. So first step will be to go get bread, go get peanut butter, go get jelly. And then you're going to close out with put away bread, put away jelly, put away peanut butter, put knife in the dish drain or whatever. Because when you do the value stream map, you're going to have that whole process from setup, making the sandwich, and then the put away. You're going to measure the stuff that actually takes place building the sandwich. So it might take 3 minutes to build the first sandwich with all the putting it up, putting it away. But based on the time that it took you, when you look at your recording times, it might be taking out the delays and moving around and picking up stuff. It might be just 30 seconds to make the next sandwich. So it's a elemental type of exercise that shows you how in big processes for manufacturing or distribution that we find shortcuts and delays that we can install to make the process go a lot smoother. Okay, so I've got us opened up to chapter 13, and it's talking about normal distribution. And if you look at the graph on there, it has like the hump with the dividing line, the average or the medians right in the middle. And this is ideally what your data is going to tell you about your operation, that it's somewhere in the middle where most of the production or most of the time that it takes to complete some type of a service are falling. I mean, you're going to have some outliers that are down here on the bottom ends of this hump, but for the most part, they're somewhere around the middle. And that just means that they're operating in a normal manner. So it basically, I'm not going to try to teach this better than the guy who wrote the class, but it's staying within this bell curve, all of your either activities or your data that you're collecting. And so if it's the likelihood of occurrence is somewhere within the top of that and the bottom of it, and they're talking about a call center, and the call duration time is from 15 seconds out to like 3 minutes or whatever. And so they find the average of what those call times are from this call center, and they can chart to see what the expectation is for how many calls like each employee could take. Okay, I hit the wrong button, didn't I? Let me go back. See if I can get it to not talk to me. There we go. So when we got these outliers that are outside of the norm, it's telling that there's like calls that exceed 10 minutes or calls that are less than like a minute. Those are ones that aren't in the norm. They're not in the average. And so the mean, which is the average, is telling us what it takes for a person to handle one of these call center calls. And so if you look at this, it's talking about that 95% of the observations will occur within a plus or minus 2 standard deviations of that middle. And we looked at those standard deviations before, where in this one, it's talking about the average weight of a guy is 175 pounds, and that if it follows a normal distribution, then it's 20 pounds. Lighter or heavier would be within that first standard deviation. And then if it was everybody else, the second standard deviation, it would be 20 added to each of them. And so it would be 135 to 215 pounds. So you can get about 99.9%. You can guess somebody's weight if they're a male being between 115 and 235 pounds. Now, there's going to be people that are heavier than that or lighter than that. But 99.7% of the males in the US are in that bracket. So you had your questions. I think I did the same thing again. Am I having a day? No. Okay. I did have a serious day today with classes. Your classmates in my first two classes today were kind of out of it from celebrating way into last night. So maybe that's what's going on here. They didn't start the fireworks until like 10:15. And so I didn't have family leave here until close to midnight. And then you got to clean up stuff. So yeah, I'm hanging in there. Hopefully everybody else is too. So I want to go back to this standard. I don't know why I can't make that quit doing that. All right, there we go. This is when a system is working. In other words, there could be some stuff that's a little bit too heavy or too light, or the call's too short or too long. But this average lets us know basically what we're operating within there. So the first standard deviation would be like plus or minus 3, and the second standard deviation would be plus or minus 6. Depending on what you're measuring, you'll know what your deviation comes into. So this is normal. This is what we hope happens when we're in a functioning service industry or manufacturing industry, that all of our tasks are completed and they look like that. So on the concept of Six Sigma, it's basically measuring how many oopses you have per million. And so if we're looking at the Six Sigma, there's a 1 Sigma, 2, 3, 4, 5, and 6. Each one of those measurements, as you go up, there's a reduced number of rejected or reject parts or reject services. So the quality is higher, the inspection's closer, and you have a tighter average that you deal with there. And this is looking at delivering parts of within a ½ inch of the standard deviation of 0.01. So if we've got, say, a bolt that is a ½ inch bolt, and it can only be used if it's only 0.01 off of that. So it could be 0.51 or 0.49, and that bolt would still work. So if we look at saying for the standard deviation of 99.97, then it's 0.5 plus or minus 6 is where they come up with 0.44 to 0.56. Only rarely will parts fall outside of that range. So if they got a machine that's making this nut that's a ½ inch, then 99% of the time it's going to fall between 44 and 56, 0.44 or 0.56 inches. And so they're saying that only 3.4 parts would come back as a reject for every million that they make. And that's where the basis of Six Sigma comes from. So let's say it didn't have to be that good, that it was just like making plastic for hula hoops, just a long piece of plastic and then it staples at the end. It might fall down to 5 Sigma or 4 Sigma or 3, where you could have 600 rejects per million and nobody dies. What they're looking at for 6 level of quality or Six Sigma is aviation, medical procedures that are life or death, nuclear plants that could be harrowing if they didn't have close monitoring and high quality precision parts that are used to put them together. So sometimes that standard is too high, and the reason it's too high is the cost associated with it. If that half-inch nut that we were looking at cost 8 cents, and we wanted it to be perfect, every one of them to be exactly a half-inch and no deviation from it, make it this Six Sigma level of quality, then the cost of the machinery to make it that perfect and the cost of the raw materials and the labor to inspect it and ensure that it's going through the process, the heat and the tempering of it and the hardening of it, the threads, all of those steps that we're creating this one little nut would make the thing cost probably $8. And so it wouldn't be very useful in manufacturing if you had to pay $8 for every nut that went onto a machine or a motor or something, and there was 100 of them. So they want to try to keep the cost down and the quality high, but this is a way that we measure what's the cost benefit. Is it worth raising the price of this particular part that much? Is it life and death? My brother that has a pacemaker, and he has a heart with a mechanical valve in it. It just has a small little medallion of metal that's got a spring in it that goes back and forth, that opens and closes the valve in his heart. That had to be perfect, because if the spring tension or the thickness of the metal or the diameter of the metal was off, then it wouldn't keep his heart function. So that part, if they manufactured just the medallion with the spring going through it, it might be, 30 cents, but it was like $30,000 when it was part of this surgery to make sure that it was perfectly made to fit into his heart. So there is a cost associated with, but there's a, he had that put in like 3 years ago. There's a calming effect or assurance, a guarantee, if you've got this high quality that occurs when that's equivalent to somebody's lifespan. Okay. This talks about air travel, Six Sigma 2, 3, 4, and then how much it costs. So you really can't use this in toy manufacturing, or if you're making just scrap metal part type stuff, nails or screws that would be used for putting together picture frames or something. You really wouldn't want to spend a lot of time and effort inspecting those to make sure that they were all perfect. Now, these terms you'll see on the quizzes, and they probably showed up in your yellow belt too. And you've got DPU, RTY, and FYT. So DPU is defects per unit. It's in the number of defects in a sample divided by the number of units sampled. So it said if the sample of 50 order was processed, a single order had 2 wrong items sent to the customer. No other defects were found in the other 49 orders. So the defects per unit would be 2 in the 50, or 4%. Seems like I'm always the 4% though. I just got a order in for fixing my freezer seal that keeps it from leaking air out. And even though I took a picture of the manufacturer's data plate that has the stock number, the model number, everything, and I took a picture of the freezer door with the seal in it and sent that with my order, they still sent me back something that's about the size of a postage stamp that would not do the job. So now I have to go through all of this hassle of repackaging it, sending it back to them, and then waiting to reorder a new seal. So their defects per unit is probably a perfectly good seal. They just sent the wrong one. So even when they're shipping things, like you get something from Amazon and it's the wrong item, their Six Sigma that they're using for Amazon is probably around the 3 or 4 level, because they have sent wrong stuff and it's a low value item. Say it's just a piece of PVC pipe or piece of plastic. Most of the times they don't even require you to send it back, because the return postage would cost more than the value of the item. So they don't put that high of a level of inspection and quality on it when it's a low value item that they're sending to you. This rolled throughput yield, and you listen to the expert, he told you had 44 seconds, he got it out. It's how a process has 90%, that means that the probability that the process will be completed without any failures is 90%. And then a first time yield is the number of goods or pieces produced divided by the number of total units that originally started through the process. So if 100 people started a training process, you know, it's New Year's Eve, everybody's starting Weight Watchers or whatever the next day, but only 75 finished, then the first time yield would be 75%. So they use these to identify if there is a process problem. Like it could be that one of the machines is out of adjustment, or they got a brand new worker that doesn't understand all the ins and outs. And that's what the people that I know in supply chain are telling me, is that these problems where you're getting the wrong packages and you're getting delays getting stuff unloaded at the port, and getting delays and trucks getting to one place to the other, is that there was a huge number of people who retired during the pandemic in their mid 60s. The average truck driver age before the pandemic was 68. So there was a lot of older drivers out there, and dock workers and port workers. And they just decided that, you know, they didn't want to go back into the workforce after being out of it for 2 years. So we have inexperienced workers out there, and these processes, and when they're tracking them, they're finding out that they have a learning curve that they're trying to work through to get this new workforce the same skill level of the folks that retired. So they're telling us to be patient. Somewhere around 6 to 8 months, they should have a better grip on what's happening with the supply chain. Okay, so the last chapter that we were covering today is pretty interesting. It's about sampling. And this is basically like we have a group of items. I got these different kinds of bubble gum flavors. And if you remember taking these different tests where you have 13 red pencils and you have 2 blue pencils, you reach into the box, what's the chance of you pulling a blue pencil out? They want you to do like a statistical analysis of figuring out what the probability of pulling that blue pencil would be. And it's a short math equation, tells you what your chances are of doing that. So this is saying if you only pull it one time, the probability would probably be off. But if you pulled it 30 times, that's a sampling. And what the industry minimum is to be called a sample is 30 of something. And so if you surveyed likely students that are going to be taking classes in the fall, how many of you would take all 4 classes, 2 in the first 8 weeks, 2 in the second 8 weeks? How many full-time students we're going to have in the fall? They want at least 30 students to take that survey to figure out what the trend was, if there was more people enrolling full-time or if there were less people. So ideally, it's 30 as a sample of any kind of a survey, or if I'm checking bubblegum flavors or what have you. So this is talking about political polling, saying that they uncovered by taking a sample of 2,000 voters, each conclusion of about 100 million people might vote. So if they surveyed 2,000 people and there's 300 million voters, 2,000 isn't much of a chunk to figure out who's going to vote what way. And so that's why a lot of times they get the polls wrong when they make some type of a forecast on who they think is going to win these different elections. But again, if it's over 30, it's a real survey. Now, out of those 2,000, you might have 1,000 of them that are 15 years old. So they're not even in the mix as part of the folks who would vote. You have to make sure that your sample has good data going in, or you'll have bad data coming out. This talks about populations. Let's see what it's got here. It's got, and that's the different parts of a sample. So it includes all members of a defined group that's to be studied. Examples include those attended a concert, all customers purchased a car from a dealership in the last month, all people who placed a call to a help center, all citizens who intend to vote. So you could have a population, you could divide that up into gender, age, race, ethnicity, zip code. You could cut that population up into all different types of market segments to drill it down to try to figure out how a certain customer would respond to an offer that you're working on. One of my students was talking about having a dog walking service because there was all these animals that people adopted during the pandemic. And he wants to have video cameras on the dog collars while he's walking them so that the owners can see where the dogs get walked. And he's going to wear a body camera. So when he arrives at their place, if they got some kind of passcode or something to let him get into the animals, they see where he's at anywhere while he's on their property. So he can ask for a higher premium because he did surveys and he asked about different people that have pets that currently have dog walking or wouldn't be interested in it. If having those additional cameras would be a difference in who they decided to do business with. And he found that there was enough people that said, yes, that was something I'd pay an extra, $1 a month to have that service. But he pulled new customers in because his competitors didn't offer that. So he got that from a sampling of pet owners that could be possible customers. So the population mean, that's usually when populations are large, we usually have no reasonable method of determining the true mean of the population. And that's the average, right? So sample is a part of a subset of a population. Since samples are subsets, we can use N, which is for number or numerator, to represent the size of the sample. Samples also have means, which we can call sample means or X over sample. They show you the math. They don't require you to do the math in this. So that's always good. So this is all these different samples coming under one population. And this is talking about working to be an event planner, 5,000 people attend, and part of your responsibilities, you got to go sample 10 people. Each one of these X's out here are 10 people coming out of the gates. And then you're going to say, hey, how did you like it? Poor to excellent, 1 to 5. And the average is 7.6. And so you could have somebody standing at this exit, say 10 minutes before the concert's over, and it was real loud and the wrong kind of music for this parents or grandparents, and they're leaving. And so this sample taker's standing here by the gate, and 10 people come out and they're all leaving early because they're not satisfied or they think it's poor experience. It was too loud. They didn't like the music. So if you just went by that one sample taken of those 10 people, you'd think the concert was not successful. So that's why they have, for marketing and for different types of surveys, they have other people take additional samples. Like after you get those 10, you might move around to another exit door and talk to 10 people. You might come back 20 minutes after the concert's over and people are still leaving. They stayed around for like autographs or whatever. And then you sample those people. So you're going to get a broader population exposure if you don't just have one person collecting the data and you don't collect it from just one place. And I think that's what they were pushing forward here on the rest of this explanation. This talks a little bit about cell phones, is it? Yeah. We don't have to get into each one of these. But if you look at this normal distribution, we've seen that in chapter 13, and it's telling about the random sampling of each one of these different frequencies. It's telling that this one is in normal, because if it was a abnormal sample, it wouldn't be shaped like a hump. It'd be a cliff, or it'd be dropped off. It'd be a sudden drop. So the data that you're going to take from this distribution sample is going to be good data. And this kind of is showing you what a normal distribution. We've got this big hump there, and then we got a population distribution. And so let's say that part of this sample, we just want to measure a part of it that is the market we're looking for. Say it's college age, what they consider college age, over 18, under 60. And so they take out anybody that's not in that age group of the market that they want to sample. Then you're going to have a population distribution that a lot of these folks back here are too young, a lot of these over here are too old, but it crosses over. It's still normal in the center there. And then this central limit theory forms us that sample sizes are large. The distribution of sample size takes the shape of a normal distribution. Okay, that's got this, the orange hump back there. This is true regardless of the shape of the population distribution. You see that it's a little bit shorter hump. But this sample is telling us how many people were in it and what their responses are, or what their ages are, or what their answers were. And so it's allowing us to make statements about a population from a small size, like 30. We can make an estimate or a guesstimate on how these people within that sample felt about it without talking to everybody. So this is just showing the different shape of a population based on the data that you're collecting and what they would look like if they were not a normal distributed population, or they weren't uniform. And without you being, you're looking at this on your phone or something, you really can't see all the different shapes of the chart, but you can see that the normal ones are the first ones, and then they sort of go into a different shape. That's saying that the data was disordered of some kind, that there wasn't either enough of a population, which remember that's 30, is how close we want to get to 30 we can, or more. Then it can be distorted. If you only had two people and they both said, I didn't like it, it really wouldn't give you a good population to choose it from. And again, it's reiterating that 30 or better is the right population for a sample size. And so I think when they ask it on the exam, they're asking about which one of these is a sample size. They'll have like 15, 12, 10, and 30. So you'll see that again when you take the exam, possibly. Okay. So that was our 3 chapters that you got taught better than I did on the review there when you came out and did it with Six Sigma. But looking at where we're at right now, it looks like we're headed towards module 6. And I don't think anybody in this class is in trouble grade-wise. Everybody looks like they're doing okay. But if there's a reason that you don't want your grade on your transcript, next week, week 6, is the last week to drop. Like I say, in our class, I think everybody's in good shape. But I give you that heads up because you go all the way to the end and you had something come up that you couldn't rejoin us and finish your assignments. You don't want a poor grade on your transcript. You want to be able to get a withdrawal and to take another swing at it. But if something does come up between now and the end of the semester that you need an extended time or whatever, just work with me. Let me know what's happening. And I've never turned anybody down on getting extended time. Worst case scenario, you come back and you say, hey, I was hospitalized, whatever. And then you say, here's the work, because all this stuff is open. Even after the class is closed, all the assignments are still open. But you send me a note saying, hey, I got caught up on my stuff. I had an incident. Could you entertain giving me a grade change? I would do that. Ideally, you go out and earn your yellow belt. That shows me that you understand the material. And that helps me leverage getting your grade to where it's at least a B based on your knowledge of the yellow belt. So we got chapter 17, 16, 17, 18 next week. That has Ben and Jerry's case study in there where they talk about the ingredients in their ice cream and how they figured out how to make sure that every bite had something in it. It's pretty interesting. Failure mode effects analysis is talking about finding out what damage a reject can do. And then, of course, we have the value stream assignment. Module 7 is a poke yoke. That's a funny one, but it's making stuff that makes them human proof, idiot proof. We'll have a couple examples to show you of those. And then our last week, we're doing the yellow belt. And I really would prefer that you do this chapter 22. We're picking up 4 chapters in week 7, because then you can go ahead and take the exam. All 22 chapters that are on the exam are finished by week 7. Week 8, it's just showing you where you can go with your yellow belt. You can go up to the green belt and black belt. So it's sort of a little advertisement that this Six Sigma puts on just to tell you that you're qualified to go to the next levels. And we have had quite a few students complete the green belt. The first half of it is a review of the yellow belt. So people that maybe haven't had it can learn what was in the yellow belt, and then they go into the new material for the second half of the green belt course. And you get it offered to you at a discount because you already are a member of their organization, and you're Ivy Tech student. So we have a special 10% off of whatever sale price you get for your codes. That's something you might want to consider. But so far, I like what I see in our responses and the work that's assignments. You guys are getting it done when it's due, and the quality work is where it's supposed to be. So I got no qualms about you folks doing a great job in class. If you haven't looked at fall yet, you might want to go out there and pick out the classes that are of interest to you, because they start figuring out what's going to run and what's not going to run based on the number of people enrolled. And we got lucky because we got to run this one with 1, 2, 3, 4, 6 people. And that hardly ever happens. So we really did get lucky getting to run this in a little bit low. And it's because we didn't have any face-to-face classes to offer you in Indianapolis for 201. So this was the alternative to taking it online. And the online classes are fine, but if you're taking them, then you see that there's a lot more busy work. They want you to spend 40 hours taking that course. And so they add assignments in there that would equate to you coming to class and spending 3 hours in class each week. And we try to avoid creating work for you when you can learn the basics that you need and not have to write 20 papers about it. You're taking English classes for that. All right, so I'm going to hit stop record, and we will answer any questions that you might have. Let's see. Here we go. So we'll see you next week. If you have no questions, I appreciate you coming to class. Thank you.
The only question I have is, can I change